Hi, in this video we are going to implement the Dijkstra's shouting yard interpreter together. So I'm going to create a new package for the Dijkstra interpreter. I'm going to have two classes, the algorithm and the application from where we are going to test our application. Okay. What about the algorithm? We have been discussing in the theoretical section that we have to store a reference to two distinct stacked abstract data type. So first, we have to store the operations such as the plus sign, the multiplication sign, divide sign, and so on. So operation stack. We have to import the java.util stack, not the stack we have implemented, the java.util stack. Okay, we could implement the stack we have implemented as well, but let's implement the java.util.stack. And I'm going to create stack for the doubles, basically for the values, so the value stack. Okay, then in the constructor, I'm going to have this that operation stack is equal to a new stack, and this that value stack is equal to a new stack as well. Okay, and then I'm going to have the public void interpret expression method with the string expression. And basically, I'm just going to create a one-dimensional array of strings from this expression. So it's going to be the expression array, which is going to be the expression dot split. I'm going to split this expression according to the white spaces. And then basically, I'm just going to iterate through. So it's going to be strings. So s in the expression array. Okay, and if this s is equal to a left parenthesis, then we are not going to do anything. We are just going to do nothing. Else if this s is equals to a plus sign, for example, then we are going to push it. So the operation stack dot push, we are going to push this string to the operation stack. Else if this s is equals to a star, then of course we have to push it to the operation stack again. So the operation stack dot push the s string. Okay, then else if this s is equals to a right parenthesis, so like this is what we have been discussing, that in this case we are going to pop off the operation. So the this that operation stack dot pop, and if the operation that equals to a plus sign, it means that we have to add two numbers. Then I'm going to this that value stack dot push. I'm going to push some value to the value stack, but I'm going to pop. So the value stack dot pop plus this value stack dot pop. So what does it mean? It means that whenever, what's the problem here? Okay, I think that we have to use something like this. Okay, so whenever it is a left parenthesis, we do nothing. That's what the algorithm told us to do. If it's a plus sign, we are going to push it to the operation stack. If it's a star, we are going to push it to the operation stack. It's going to represent a multiplication. It's going to represent addition. If it's going to the right parenthesis, we are going to pop off the last operation and we are going to get the last two values of the value stack, going to add them together if it's an addition sign, and we push the value back to the stack. And basically, as if the operation that equals a multiplication, then we are going to do the same basically, but instead of adding the items, we are going to multiply them together. So we multiply them together. And else we know that if it's not a left parenthesis, if it's not a plus sign, if it's not a star, if it's not a right parenthesis, then it's going to be a value. So we are just going to push, so this dot value stack dot push the s. Okay. Of course we have to cast it, so double dot parse double for the s. Okay. So basically, because we know for certain that if it's not a left, not a right parenthesis, not an operation, it's going to be a value. So we are going to cast it and push it to the value stack. And of course, if it's a right parenthesis, we have to make the operation. This is how Dijkstra's interpreter works. Okay, this is just an algorithm. Then I'm going to have another method, public void result. It is going to print out this dot value stack dot pop. Okay. So in the application, I'm going to have a main method. First of all, I'm instantiate the algorithm itself, so is equal to a new algorithm. Then I'm going to have the algorithm that interpret expression, and I'm going to specify some expression. For example, 1 plus, just make sure that you make enough white spaces because the algorithm is going to split the expression according to the white spaces. So if we do not make any white spaces, then it's going to be interpreted as a single expression, for example, an operation or something like this. So we have to make the spaces. Okay, so 1 plus 2, for example, times 2 plus 1. Okay, so I think that's all about the expression. It's going to start with the left parenthesis, it's going to end with the right parenthesis, and basically we would like to multiply 1 plus 2 times 2 plus 1. It should yield 9. Okay, then the algorithm dot result, because the last item, so the result of the algorithm, is going to be pushed to the value stack, so that's why the result is going to be the value stack dot pop. So let's see whether it's working fine or not. Yeah, it's working fine. So basically, that's the core of the interpreters in the main, that we are going to have the expression, for example, a source code, and we are going to process it line by line, expression by expression, and we have to use some stack abstract data type. Okay, not always, but usually interpreters rely heavily on stacks like this. We just push the operations, we just push the values, and if there's a right parenthesis, we are going to pop off the operation. If it's a plus, then we are going to pop two values out of the value stack and going to push the result back to the stack, and it's the same for multiplication. We are going to pop the last two items out of the stack, we multiply them together, and we push the result back to the value stack. So this is how interpreter works. Thanks for watching.